ordering cost there is no change here, and accordingly this model will depict optimum order size under root 2 C naught D Cc, that is all same as equal to the previous model, the basic EOQ model. So, there is only one difference here, that we associate this factor 1 minus D by P. Okay. Now, moving to the third model. In case of third model, now this is the model with shortages. Now, here we have the underlying assumption that whatever the shortage that we receive, now that is back ordered. मान लो ਅਸੀਂ ਜਿਹੜਾ Q amount ਅਸੀਂ receive ਕੀਤਾ ਇਨਵੈਂਟਰੀ ਦਾ, ਉਹ ਸਾਰੇ ਦਾ ਸਾਰਾ ਫਿਊਚਰ ਡਿਮਾਂਡ ਲਈ ਯੂਜ਼ ਨਹੀਂ ਕਰਾਂਗੇ, ਉਹਦਾ ਜਿਹੜਾ ਥੋੜਾ ਜਿਹਾ ਪਾਰਟ ਹੈ ਉਹ ਯੂਜ਼ ਕਰਾਂਗੇ ਪਿਛਲੇ ਪੀਰੀਅਡ ਦੀ ਅਨਮੈਟ ਡਿਮਾਂਡ ਨੂੰ ਫੁੱਲਫਿਲ ਕਰਨ ਵਾਸਤੇ. Okay, the quantity that we receive, the part of it will be used to meet the unmet demand of the previous period, that is back ordered, and finally all the demand is satisfied. Now, this model is like this ਕਿ ਜਿੰਨੀ ਸਾਡੀ ਇਨਵੈਂਟਰੀ ਸੀ ਉਹ T1 ਦੇ ਵਿੱਚ ਖਤਮ ਹੋ ਗਈ, ਇਸ ਦੇ ਵਿੱਚ ਸਾਡੇ ਕੋਲੇ ਸ਼ਾਰਟੇਜ ਪੀਰੀਅਡ ਰਹਿ ਗਿਆ. Now, here were the shortages. तो जदों असी after T, when we received Q, then for the next period inventory available is not Q, it is Q minus S, because a part of this Q, that is S, will be used for meeting the orders of the previous period. So, inventory available for the next period will not be Q, but instead it will be Q minus S. Okay. Similarly, this S is the shortages in a particular period. Now, this is the level of the shortages. So, that shortages remain in the time, let us say T2. So, we split the total T into T1 and T2. Now, the point here is we need to understand in such a situation that what shall be the optimum quantity at one time under these shortages. At the same time, what shall be our optimum shortages? Okay. So, in that case our total shortage cost will be Cs into S square over 2Q, and our total carrying cost will be Cc into Q minus S square divided by 2Q. Now, in that case we have worked out like this. Now, for instance, in this case, so let us say, so in that case the area will be half Q minus S. Okay. So, into T1, T1 is the period. So, for this period there will be an inventory divided by T, and this T1 by T finally we have to work out. So, half Q minus S into T1 divided by T, because in the rest period T2 or S there is no inventory, inventory is 0. For example, if you consider let us say S and T2 divided by T, since here there is no inventory, it is 0, this component becomes 0. So, this T1 by T, finally this T1, basically T we have worked out, if D is the daily demand, Q is the quantity, total quantity, then this is Q by D, and T1 will be Q minus S divided by D. So, when you take T1 by T, it will be Q minus S divided by D divided by Q D. So, this will be Q minus S divided by Q. So, here we already have, so you can substitute this value here. So, finally, this becomes half Q minus S square divided by Q, or you can say Q minus S square divided by 2Q. Now, this will be the inventory average inventory you can say in that period T. Similarly, we can have average shortages. So, in this period there is no shortage. So, this now this component becomes 0 and here in this period it is S into T 2 divided by T and same case here. So, in case of S, so it is shortage is S. So, same way here. So, S by D divided by Q by D. So, putting the same thing here, this will become S square, just like it has become Q minus S square, it will become S square divided by 2 Q. Now, these are our average shortages. So, now we will employ the respective cost here. Yes. So, these are the average shortages S square by 2 Q and these are the average inventory. So, carrying cost, total carrying cost, multiply it carrying cost per unit. Now, here shortage cost per unit, that is total shortage cost, total carrying cost, total ordering cost as it is, total inventory cost, sum of these three costs and finally, differentiate with respect to Q as well as S and you will get optimum Q with this formula and your optimum shortages, that is equal to Q optimum into Cc divided by Cc plus Cs. Now, we have this final model here. It is also known as EOQ model with quantity discounts, okay, or it is a price break model. Now, in this model, now there CD, C is the per unit price of the item, D is the annual demand. For instance, let us say we would be getting it at 10 rupees per unit and 1000 units is the demand. So, in that case total CD will be 10,000 rupees. Okay. Now, here economic order size remains same. So, in that case let us move with this thing. So, here we have this example. Now, there are certain price slabs, quantity slabs, accordingly we have the prices. If we give an order from 1 to 49, then price charge will be 1400 rupees. From 50 to 89, it will be 1100 rupees and if we buy 90 plus, then it will be 900 rupees. Now, these are the values of the ordering cost, carrying cost and this is the total demand. Let us say this is a case of computers. Okay. So, total annual demand is 200 for instance. Now, in that case what we do where there is a price variation? First of all, we find Q optimum for the slab starting with the first one. Now, here Q optimum considering this basic EOQ formula 2 into 2500, then 200, then 190. Okay. So, it is 72.5, 72.5. Now, this 72.5 here we see that it falls in this slab, it falls in this slab. Okay. So, that is why in that case if 72.5 is this, then in that case we will be getting the price of 1100. Now, applying all this thing, okay, considering total cost here, we have all these values given and here we have find out Q optimum 72.5. So, this cost comes out to be 2,33,784. But at the same time we compare this cost with the next higher level, okay, with the next higher slab you can say and with its minimum quantity, okay, with its minimum quantity. So, next higher slab is 90 plus and its minimum quantity is 90. Now, let us compare here. When you consider Q 90, that means minimum of the next higher slab. Okay. So, in that case considering 90 as a order size, our cost comes out to be 1,94,105. That is less as compared to as we have worked out in case of Q optimum. So, in that case, comparing their total cost, our order size will be 90, not 72.5. So, what we have done here, first of all, we have found the Q optimum, then we have seen in which slab it lies, okay, and then putting the value there, we have found out the total cost. Okay. Then we have gone to the minima of the next higher slab. Why next higher slab? Because their price will again be reduced. Okay. So, whether we buy 90 or more than 90, we are going to get 900. So, why to buy more than 90? Because we would be adding more to the carrying cost. Okay. So, that is why we have considered 90. Okay. जिन्ना सानू discount सी उत्थे मिल जाना. So, that is why when we compare like this, so here we have found out that it was less in case of the minima of the next higher slab. Okay. So, in that case we will go for this thing. Now, considering for instance, if carrying cost is given as a percentage of price, in that case carrying cost was fixed, was 190 rupees or dollars you can say per unit. But here if carrying cost is given, if we apportion carrying cost, okay, we absorb carrying cost as a percentage of, let us say, selling price. Okay. So, right at the beginning we have seen the number of methods in which carrying cost can be expressed. So, considering this thing, so let us say it is 15% of this. So, accordingly our carrying cost will vary. Here our carrying cost is this much, here our carrying cost is this much, and here our carrying cost is this much, because carrying cost is also varying according to the price that we have been offered. Okay. So, in that case, starting with the first one, the first carrying cost in this case. So, we have seen that what is Q optimum. In this case Q optimum is 69 units. Okay. Now, we have to see whether these 69 units are feasible here. No, not feasible, reason being that this is outline, okay, not falling within this range 0 to 49. So, it is outside here. So, then we will move to the next case here in this slab. Considering this, here our Q optimum comes out to be 77.8. Okay. So, that is very well true here, 50 to 89 falls very well within here. Okay. So, 77.8, yes, it is feasible. Then find the total cost here. So, we have found the total cost here, that comes out to be 2,32,845. Again we will go for the next case, considering this minimum of the next higher slab. Okay. So, in that case we have seen if we go for 90, then the total cost will be minimum. Okay. Total cost will be less than this if we go for the next higher slab, okay, and at its minima. So, that means next higher slab is more has a more advantage for us as compared to this slab. So, that is why we would be interested to go for the next higher slab, but in the next higher slab what is the optimum order size, we would be interested in knowing. Okay. One thing we have made sure that next higher slab is good for us, but in next higher slab what shall be the optimum. So, now here we will work the optimum in the next higher slab, considering the value of CC of 90 plus, but here it comes to be 86.1, and this 86.1 is again outside the slab. Okay. It is out of the slab because this slab starts with 90. Okay. So, 90 shall be the minimum units. We cannot have next slab is profitable for us. Okay. It has some more advantage for us, but in that case optimum point is 86.1. 86.1 is not feasible here, then we have no other option but to go for minima of the next higher slab, that is 90. So, this is how we deal with this kind of situation when price varies. I hope you might have understood all the concepts and you will find it is interesting, and at the same time you can apply these techniques at your workplace, at any place where you are well concerned with inventory. Thank you so much.